Okay guys, today I'll be discussing question from the second subtopic of chapter 5, which is geometric progression. Okay, so what is the general property of geometric progression? Okay, so if you take any two consecutive terms of a geometric progression, the ratio must be same, meaning if we take term number 2, we divide with term number 1, the value that we get will be equivalent to term number 3 divided by term number 2. Okay, and this value is actually known as common ratio. Okay, so meaning in order to calculate common ratio, we have to take term number 2 divided by term number 1, or the third term divided by the second term. Okay, now let's try a few questions related with this concept. Okay. So question number 1, determine whether the following sequence is a geometric progression. So how to check? Okay, so let us identify the terms. So T1 is equals to 120, T2 is 40, T3 is equals to 40 over 3. Okay, I'm going to take T2 divided by T1. It's going to give me 140 divided by 120. So this will be equivalent to 1 over 3. And similarly, if we take T3 divided by T2, it's going to be equals with 40 over 3 divided by 40. Okay, and the value is also 1 over 3. Okay, meaning this 1 over 3 is actually what we call as common ratio. Okay, and remember what is ratio? Ratio is T2 divided by T1 or T3 divided by T2. Okay, so a term divided by the previous term is called as common ratio. Okay, so since the ratio that we get for T2 divided by T1 and T3 divided by T2 is same, okay, it's going to call as common ratio. Okay, so this sequence actually a geometric progression. Okay. Sequence is a geometric progression. Okay. Now let's look at the second question. So here we're going to take T2. In this case, T2 is 0.003 and T1 is 0.03. Okay, so 0.003 divided by 0.3 is going to give us 0.1. Okay, and similarly we calculate T3 over T2, 0.0003 divided by 0.003, and the answer is 0.1. Okay, so the ratio that we get is same. Okay, so therefore sequence is a GP. Okay, so I represent GP for geometric progression. Okay, next, how about C? Okay, for C, T1 is equals to x plus 1, T2 is equals to 2x, and then T3, okay, T3 is 5x plus 12, and T4 12x. So T2 divided by T1 is equals to 2x over x plus 1. Okay. Whereas T3 divided by T2 is equals to 5x plus 12 divided by, okay, 2x. Okay, and actually we no need to find the value for T4 divided by T3, yeah, since these two values is already not same. Okay, so therefore this sequence, okay, not a GP. Okay, so remember, if the ratio between two consecutive terms, meaning you have to take a term divide with the previous term, okay, T1 divided by T2 is not common ratio, T2 divided by T1 is common ratio, T3 divided by T2 is common ratio. Okay, so we have to take a term divide with the previous term, okay, not the next term, in order to calculate the common ratio. Okay, so let's look at this question. Complete the network diagram below. Given the relationship of each of the following network is a consecutive term in geometric progression. I give you a few seconds for you to go through the diagram. So the value here is 8. Okay, this is 1 over 2. Okay, so let's focus on this section. In fact, you also can focus on this one. Okay. So what would be the value that we should put in this circle? Okay. Yes, the answer is 4. Right? So how we get 4? 2 times 2 we get 4. 4 times 2 we get 8. Okay. And if we want to do the what you call a complex calculation, okay, maybe we can start to put this as x. Okay. So 2, okay, sorry, and let us assume this as T1, this as T2, and this as T3. Okay, so x over 2 is equals to 8 over x. Remember, this is T2 divided by T1, and this is T3 divided by T2. Okay, so both will give us common ratio. So we solve this. X squared is equals to 16, and x is equals to, okay, it can be either positive or negative 4. Okay, but in this case I'm going to take 4. Okay, so since the rest of the values are positive, so we're going to take, okay, x equals to 4. Okay, so when this value is equals to 4, okay, 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 we can continue with another section. Okay, now let's say this is y. Okay, so similarly you can take 1 over 2 dy by y equals to y over 8. Okay, so in this case, it's going to be 1 over 2 times 8 equals to y times y will give us y squared. Okay, and 4 is equals to y squared. So y is equals to, okay, it can be either plus or negative 2, but in this case I'm going to take y as 2. Okay, so the value here is 2. Okay, so 1 over 2, okay, it times this with, okay, 4. Okay, we get how much? We get 2, and then 2 times 4 we get 8. 8 times 4 will give us 32, right? Okay, the last one. Okay, let's say this is z. Okay, so 4 over z equals to z over 1. Okay. So if we solve this, okay, 4 times 1 will give us 4, z times z will give us z square. Okay, so z square is equals to 4, z is equals to plus minus 2. Okay, since the rest of the values are positive, so we're going to assume z as equals to 2. Okay, so here it's going to be 2. Okay, so 1 times 2 we get 2, 2 times 2 we get 4. Okay, if we notice, we have a sequence with different common ratio. Okay, you want to copy which one? Scroll up a bit. Okay, the first section is actually quite easy lang, huh? Okay, what you need to do is you take t2 divided by t1, and then t3 divided by t2, or t4 divided by t3. If the value that you get is same, then it's going to be what you call geometric progression. So if the value of the ratio is not same, then it's not geometric progression. Okay. And using the concept that we already discussed earlier, be able to solve question number 2. Okay. Okay. Next, question number 3. Okay. So first, t1 is equals to x minus 2. t2 is x plus 1, and then t3 is equals to 4x plus 4. Okay. So I'm going to give you about 2 minutes. So use the concept that I already given you earlier, which is t2 divided by t1 equals to t3 divided by t2 to solve this problem. Okay, we already have t1, t2, t3. Yeah? So substitute the values accordingly into this formula and find the positive value of x. Okay, positive value of x. And once you get the value of x, then you can calculate, okay, what is the value of t1, t2, and t3. And later, you can come out with the common ratio. Okay. So I'm going to give you the first step, which is t2 divided by t1, x minus 2. And then t3, 4x plus 4. We divide with x plus 1. Okay, so we do the cross multiplication. You're going to get x plus 1 square equals to 4x plus 4 multiplied with x minus 2. Okay, so if you expand this, you're going to get x square plus 2x plus 1 equals with 4x square. Okay, 4x times with negative 2 will give you negative 8x. 4 times x, positive 4x. 4 times negative 2 is negative 8. Okay, and let us bring all the terms towards left. So this will give us negative 3x square. Okay, negative 8x. Okay, you transfer to the left hand side. 4x also you transfer to the left hand side. Okay, so this will give us 2x plus 8x and x minus 4x. So it's going to be positive 6x 1 minus 1 minus negative 8. So it's going to be 1 plus 8. So this will give us positive 9. Okay, and let's simplify this. We get x square minus 2x minus 3 equals to 0. How we get this? We divide the whole equation, okay, with negative 3. Okay. Now, in order to find the value of x, we have to factorize this quadratic equation. So the factorization should give you x, okay, minus 3, x plus 1 equals to 0. So the value of x is equals to either 3 or negative 1. But since the question asks you to choose only the positive value, okay, therefore we're going to reject this. Okay, reject this. So the value of x is 3. Okay. And later you can find the first 3 terms because the question asks you to list the first 3 terms. When x is equals to 3, t1 is equals to 3 minus 2, which is equals to 1. Okay. T2, 3 plus 1, which is equals to 4. And T3, 4 times 3 plus 4. So you get 12 plus 4, which is equals to 16. So the first 3 terms are 1, 4, 16. Okay. So meaning 1 times 4 you get 4, 4 times 4 you get 16. Okay. So how about common ratio? Common ratio R is equals to 4 divided by 1, which is equals to R. Okay. You also can take 16 divided by 4. Okay, guys, any questions? So there are 2 important things. First of all, in order to identify whether a sequence is a what you call geometric progression, okay, you have to take T2 divided by T1 and then T3 divided by T2 or T4 divided by T3. If the value is same, then it's going to be geometric progression. Okay, and secondly, R is equals to T2 divided by T1 or T3 divided by T2 or T4 divided by T3 or T10 divided by T9. Okay, that's going to be common ratio. Okay, so if you don't have any other question, so we're going to see on what I call how to find the nth term of a geometric progression. So the formula that we're going to use is Tn equals to a r to power of n minus 1. Okay. So in this case, Tn is the nth term. Okay. Tn is the nth term. And a is the first term. Okay. and then R is the common ratio. Okay? Common ratio. Okay. And what is N? N is number of terms. Okay, so let's look at this question. Okay, you are given T1. T1 is 12 and T3 is 27. The question asks you to find T5. Okay. So T1 is actually A. Remember, A is actually equals to T1. So it's equals to 12. So how about T3? Okay, T3 is actually A R power of 3 minus 1, which we can write as AR to power 2. Okay? If T3, AR power of 2. If T4, AR power of 3. If T5, AR power of 4. Okay? So the power here, you should reduce by 1. Okay, now. So AR square, which is T3, equivalent to 27. And you already know the value of A, right? Okay, you already have the value of A, which is 12. So let us substitute the value of A with 12. So 12 R square is equals to 27. R square, 27 divided by 12. Okay, how much is that? 27 divided by 12. Guys, 27 divided by 12. Okay, it's 9 over 4. And R is equals to square root of 9 over 4. Okay, so we will get two possible values. It can be either 3 over 4, sorry, 3 over 2, or negative 3 over 2. Okay. But for this case, let us choose, then let's assume, okay, assume R is equals to 3 over 2. Okay. So if R equals to 3 over 2, and initially we already have the value of A, which is 12. Now you can calculate what is the value of T5. T5 should be AR power of 4. Okay. Okay. So A is equals to 12 R 3 over 2 power of 4. And key in this into your calculator and calculate the answer. So the answer should be 243 over 4, or which is also equivalent to 60.75, which is also equivalent to 63 over 4. Okay, so let's proceed with the next question. Okay, T1, T1, yes, of course, is equals to A. Okay, and then the second piece of information is T3, and T3 is equals to A plus 24. Okay, so T3, what is T3? T3 should be AR square. Okay, let me write this. A equals to T1, T3 is equals to AR square, T2 is equals to T3 I replace with AR square, and then for T2 I put AR and then plus 24. Okay, and since we already have the value of A, right, we already have A, so let us substitute A with 4. So 4R square equals to 4R plus 24. Okay, so this will give us a quadratic equation: 4R square minus 4R minus 24 equals to 0. So when you factorize this, but before factorize possible, you try to simplify. So in this case, I'm going to divide the whole thing with 4. So it will give me R square minus R minus 6 equals to 0. And if we factorize this, R minus 3, R plus 2 equals to 0, and R is equals to either 3 or negative 2. But since the question wants us to just take the positive values of R, I'm going to choose R equals to 3. R equals to 3. Okay, any questions? Okay, so in that case, okay, I want you to try this question. Okay, it's actually much more easier compared to the previous question. You are given the value of A and the fifth term. Okay, find the value of R. So once you already get the answer, okay, you can type the answer in the comment section. Or you can switch on your mic and answer me. Guys, anyone? Okay, Elvin, what is the answer? Elvin Ding Tai Yong. Chang Mei Lee. Okay, 4 or 5. Okay, so let's check whether the answer is 4 or 5 or not. Okay. So A is equals to 50 T5, right? So what is T5? T5 is actually AR to power 4. So let us equate, okay, AR to power 4, okay, with 20, 12 over 25. Okay, so I'm going to substitute A with 50. Okay, so 50 R to power 4 equals to, so possible you rewrite this value in what you call in improper fraction, which is 512 over 25. Okay, and if you divide this with 50, you're going to get r power 4 equals to 256 divided by 25, right? Okay, sorry, I made a mistake here. So it should be 256 over, okay, 625, right? Okay, yeah, thank you. So r, okay, so you root 4, right? 256 over 625, and then you get r equals to 4 over 5. So how to key in this into calculator? So we are using 570 ms. Okay, so there are two options. The first one will be like this, huh? Okay, 256 over 625, put them in a bracket, and then root. Okay, so power 4, when you transfer to the, okay, right hand side, become power 1 over 4. So here I'm going to put this as power 1 over 4. Okay, and then close the bracket, press E equals 2. So we get the answer 4 over 5. Okay, and this is the second method. Okay, in order to get the root of 4, you have to key in 4 and then shift the power button, or the root button. Okay, so you get, okay, what do you call root, and then you key in the value, so you also get the same answer. Okay, 4 over 5. Okay, now let's proceed with the next question. Okay, given negative 3, 6, negative 12, okay, and then after certain what do you call terms, and finally we get negative 192. So find the number of terms. Okay, so we know that t1 is equals to negative 3, t2 is equals to 6, t3 is equals to negative 12. But how about, okay, negative 192? Okay, we don't know which term is this. So therefore, we're going to put this as the nth term. So tn, because we don't know what is the value of n. Okay, so the nth term is negative 192. So what is the formula to calculate the nth term? The formula is a r to power n minus 1. So we equate this with negative 192. And what is the value of a? This is a. This is a. And then the value of r. Okay, r can be calculated either using t2 divided by t1 or t3 divided by t2. So in this case, I'm going to choose the second term and the first term. Okay, so the value of r is negative 2. So a equals to negative 3, r negative 2, power of n minus 1. We equate this with negative 192. Okay, And remember, we cannot multiply negative 3 with negative 2 because the power is not same. So therefore, we have to bring this negative 3 to the right hand side. Okay. So negative 2 power n minus 1 equals to 192 divided by 3. Okay. So negative and negative will cancel each other, and this give you positive 64. Okay. Okay, next. Okay, by using trial and error method, you can find the power of, okay, negative 2, so that you can get a value which is equivalent to 64. Okay, so how to do that? Let's put negative 2 power of power what? Okay, let's try with 4. I just get 16. So we increase the power to power of 5. It's 32. Okay, let's change it to 6. Yes, we get 64. So the power here should be 6. Okay, so since the base on the left and the right is same, the power of the index also must be same. So therefore, n minus 1 should be equals to 6. So n is equals to 7. Okay. Okay, so the next question. Okay, so this is going to be very direct forward. The question just asks you to find the value of r. Very easily we can find the value of r. We just take the second term, which is 0 0.0, okay, 012. We divide this with 0 0.12. Okay. Okay. So the answer is 0 0.01. Okay. If you take the third term, 0.000012, and then you divide with the second term, which is 0.0012, you're also going to get the same answer. Okay. Okay, next. Okay. Given T2 equals to 8 over 9 and T6 9 over 2, find T5. Okay. So what is T2? T2 is equals to AR, and T6 is equals to AR to power 5. Okay. And T5 AR to power 4. Okay, so let's form the equations using the information that given. AR equals to 8 over 9. So this is the first equation. And the second one is AR to power 5 equals to 9 over 2. Okay. Since we already have the value of AR, I'm going to substitute AR. So if we substitute AR, actually this will become AR, okay, and then multiply with AR to power 4. Okay, 9 over 2. So AR is 8 over 9. 8 over 9, okay, times R power 4, 9 over 2. So what is R to power 4? Okay, it's actually equals to 81 over 16. And just now I already teach you how to, okay, root, right? So R is equals to 3 over 2. Okay, so actually you will get positive negative 3 over 2, but plus minus, okay, negative plus minus 3 over 2. Okay, unless in the question it mentioned uh, the r is positive or r is negative. R negative means you choose negative 3 over 2. Okay. R positive, then you choose 3 over 2. Okay, next. So I want you to try this question. Okay, remember T2 is equals to T3. T3 is equals to AR to the power 2. And T10 should be AR to the power 9. Okay, why R power 5 will become 4? Because the formula, right, Tn is actually ARn minus 1. So if this is 5, right, if this is 5, then this become 5 minus 1, 4. Okay, so if this is 3, 3 minus 1 become 2. So I already simplified the working. So let's proceed with this. Okay. R. So what is the value of R? Is R 1 over 2. 1 over 2 power of 2 is equals to 1 over 6 A. So how much is A? Okay, so it should be okay 2 over 3. Okay, next T10. T10 is equals to AR to the power of 9. So we already have the value of A, which is 2 over 3, and then R 1 over 2, and then power of 9. Okay. Then you can calculate the answer is 1 over 768. Okay. Next question. T5. Find the T5 and for the sequence x plus 1, and the second term is x plus 3, and the third term is x plus 8. Okay, so here what you need to do is first you have to find the value of x, and later you have to find the value of first term, second term, and then calculate the value of r, and at last you can find T5. Okay? So basically there are 3 steps. Okay. So first one, T1 is x plus 1, T2 is x plus 3, T3 x plus 8. So I'm going to take T2 divided by T1. So x plus 3 divided by x plus 1 is equals to T3 x plus 8 divided by T2, which is x plus 3. Okay. So So when you do the cross multiplication, x plus 3 square equals to x plus 1 multiplied with x plus 8. Okay. If you expand this, then you get x square plus 6x plus 9 equals to x square plus 8x plus x plus 8. Okay, and you can cancel out the x square on both sides. Actually, x square minus x square will be eliminated. Okay, so 8x plus x, you get 9x. 6x minus 9x will give you negative 3x. Okay, 8 minus 9. Okay, 8 minus 9 will give you negative 1. And the answer is 1 over 3. So x is equals to 1 over 3. So what is T1? T1 is 1 over 3 plus 1, which is 4 over 3. T2, 1 over 3 plus 3. Okay, you're going to get 10 over 3. And then T3, 25 over 3. Okay. So how I get this value? Substitute the value of x 1 over 3, okay, in this what you call expressions. Next, let us calculate the value of r. R is equals to T2 divided by T1, which is 10 over 3 divided by 4 over 3. Okay. So basically we will get 5 over 2. Okay, next, T5. That's the last step, T5. T5 is AR to power of 4. So what is A? A is equals to, this is A, 4 over 3 multiplied with R, which is 5 over 2 power 4. Okay, so the answer is 625 over 12, which is also equivalent to 52 1 over 12. Okay, so let's proceed with the next concept, which is sum of the nth term of a geometric progression. So basically we have two formulas. The first formula normally we use when r is, modulus of r is greater than 1. The second formula when modulus of r is less than 1. But anyway, you can, okay, if you didn't follow the rule also, you're going to get the same answer. Okay, meaning for any value of r, you can use either the first formula or the second formula. The final answer is going to be same. But anyway, in this calculation, I'm going to use this rule. First, A, so R, what do you call A is equals to 0.02, and then the value of R, 0.04 divided by 0.02, going to be 2. Okay, so R is actually modulus R is greater than 1, so we're going to use the first formula. Okay. So S12, because we have until the 12th term, S12 is equals to 0.02 multiply with 2 power of 12 minus 1 divide by 2 minus 1. Okay, you can key in this into your calculator and find the answer. Okay, so the answer is actually 81.9. Okay, next, for question B, A is equals to P R. So let's calculate R. R is actually P3 divided by P. Okay, I mean the second term divided by the first term. So this is going to be P squared. And then N is actually equals to how much? Okay, is it 21? Okay, you are wrong. Okay, N is not 21. So you have to calculate N first. So how to find N? Okay, so here we're going to use the Tn formula. Okay, Tn is equals to AR to power n minus 1. So in this case, if P to the power 21 is equals to A, which is P, and then R, which is P squared, okay, power of n minus 1. Okay, so P power 21 divided by P is power 1. So what you're going to get is P21 minus 1. So P20 is equals to P to the power of 2n minus 2. Okay, and later is going to be 20 equals to 2n minus 2. Okay, and the value of n is 11. Okay, so once you already calculated the value of n, next we can calculate S11. So S11 equals to the value of A, which is P, okay, value of R, which is P square, to power of 11, okay, minus 1, okay, divided by P square, which is the R, minus 1. Okay, so if you expand this, you're going to get P bracket P22 minus 1, okay, divide by P square minus 1. Okay, okay, good. Okay, so I'm not going to discuss C because the working is quite similar to A. So I'm going to skip question C. Okay, next, let's look at question number 2. Okay. Find the number of terms if the sum of the geometric progression, okay, 3000, okay, 500, 700, under 40, and the sequence actually goes on. Okay, okay, and then the sum is actually 4368. Okay, now the information that we have is A equals to 3500, okay, and then T2, this is actually T1, T1 is equals to A, T2 is 700. Okay, so from here we can calculate the value of R is equals to T2 divided by T1. So 700 divided by 300, sorry, 3500. This will give us, okay, 1 over 5. So the value of R is 1 over 5. Okay. So let me finish this first. Okay. So R is equals to 1 over 5. So how about this value? This is actually Sn. Sn. So let's equate Sn. The formula is, okay, so since R is 1 over 5, we can use the second formula, which is A 1 minus R to power n divided by 1 minus R. Okay. So we already value of Sn. Sn is 4368. And I'm going to equate this with A, okay, which is 3500, 1 minus R, okay, which is 1 over 5. Okay, 1 over 5 is also equal to 0 0.2. Right? So I'm going to use 0 0.2 because it's easier to write. Oh, n, close the bracket, okay, and 1 minus 0 0.2. Okay, so we proceed 4368. Okay, multiply with 0 0.8 because 1 minus 0 0.2 will give you 0 0.8. Okay, equals with, okay, 3500, 1 minus 0 0.2 to power n. Okay, and later this 3500 also we can transfer to the left hand side. Okay, so 4368 times with 0 0.8 divided by 3500. So whole thing is 624 over 625. 625 equals to 1 minus 0 0.2 power n. So 0 0.2 to power n is equals to 1 minus 624 divided by 625. And later this will give you 0 0.2 to power n equals to 1 over 625. Okay. Okay. So 0 0.2 to power n, 0 0.2 to power what will be equivalent to 1 over 125. Okay, so you can use the trial and error method. Let's key in 0 0.2 power of, okay, let me try with power 4. Okay, and you can convert this to decimal fraction. Yes, 0 0.2 power 4. Coincidentally, the first value itself give the required answer. Okay, so this should be power of 4. So meaning the value of n is 4. So there are how many terms in this sequence? Okay, 4 terms. Okay, 4 terms. Okay, so I will scroll the previous question. Okay. Okay, so let's proceed with another concept related to geometry progression. which is sum to infinity. Okay, so when we going to use this concept, okay, the condition is the modulus r must be less than 1. Okay, so for example, when r is equals to 1 over 3, yes, you can use this formula. Okay, r 1 over 2, r negative 2 over 3, or r negative 1 over 5. Okay, for all this you can use this. Okay, but when r is 3 over 2, you cannot use this formula. Okay, so what will happen if you get this specified r? Okay, actually the next term is going to be smaller and smaller. Okay? For example, if you look at this sequence, okay, the first value is 1500, and the second one become 500, and the third one become 166, 2 over 3. So you can see that the value is actually become smaller and smaller. Okay, so when you sum up all these values, actually it will approach a certain value. So that value is actually sum to infinity. Okay, so in this case, we want to calculate sum to infinity. It's very easy because you already have the value of a, which is 1500, and then you can calculate r 500 divided by 1500. This will give you 1 over 3. So what is sum to infinity? Sum to infinity is equals to a, which is 1500, divided by 1 minus the value of r, which is 1 over 3. Okay, so 1500 divided by 2 over 3. Okay, so this will give you 2250. Okay, so sum to infinity actually sum of all the terms, okay, in this what you call geometric progression starting from 1500. Okay, next. Okay, okay. Wilson loan, okay, 15,000 to buy a motorcycle. Every year he managed to reduce 50% of his total loan. Find the maximum amount paid by Wilson. Okay, so in this case, the value of A is 1500. Okay, R is equals to how much? Since the value reduced 50%, right? Okay, it's 50%. R is going to be 1 over 2. Okay, so sum to infinity is A over 1 minus R. So 1500, sorry, 15,000 divided by 1 minus 1 over R. Okay, so this will give us Rm 30,000. Okay. Next, okay. Given that the sum to infinity is 4,480 and the common ratio is 1 over 2, find the first term of the geometric progression. So here you are given the value of sum to infinity and the value of r. You are required to find the value of a. So sum to infinity is equals to a over 1 minus r. So this value is sum to infinity. So 4,480. I equate with a divided by 1 minus r. R is 1 over 2. Okay. So a is going to be equals to 2,200. Okay, next. 4.818181. So this type of numbers is called as recurring decimal. Okay, so we look at this number, right? 818181. So this 81, these two digits will recur recur or repeat forever. Okay. For example, if you take 2 divided by 3, you get 0.666666. So 6 actually will recur or repeat forever. Okay. Okay. Now the question asks us to express this value, okay, in the form of fraction. And this concept also you already learned in the previous chapter, which is in index, surd, and logarithm. Okay, so you also can use the concept from the previous chapter to answer this question. Okay, but anyway, here we're going to use a different method. Okay, so 4.818181 can be written as 4 plus 0.81 double dot. Okay, so what is the meaning of double dot? Meaning these two numbers actually recur. Okay, 0.81 double dot actually equals to 0.81 plus 0.0081 plus 0.000081 plus, okay, and the list goes on. Okay, so here this is going to be the first term, second term, third term, right? So A equals to 0.81 and R is equals to 0.0081 divided by 0.81, which is equals to 0.01. Okay, so now I'm going to teach you a shortcut. Okay, when you write 0.81 double dot, this is actually A. Okay, if you have two dots, meaning R is equals to 0.01. If you have one dot, meaning R is equals to 0.1. If you have three dots, then it's going to be 0.001. Is that okay? So that is the shortcut. So 4 plus, the meaning without doing this, I can straight away do this calculation. Okay? So A is 0.81 divided by 1 minus R. Since I have two dots, R is going to be 0.01. Okay, now let's key in this into the calculator. 4 plus, or maybe you can calculate this and 4. Okay, 81 divide 1 minus 0.01. Okay, so the whole thing is actually 53 over 11. Okay, initially you already given that this is actually equal to h over 11. So what is the value of h? H is equals to 53. Okay, so next we're going to see some problem solving questions related with geometry progression. Okay, so go through this question. A wire is cut into few pieces, okay, in which 10x centimeter, 4x plus 20 centimeter, 2x minus 10 centimeter are the three consecutive pieces of geometry progression. Find the longest piece if 10x the second longest term. Okay, so first what you need to do is you have to calculate the value of x. So how to do that? So these are the three consecutive terms, but they are not first three consecutive terms. So by right you cannot write this as t1, t2, t3. Yeah? Okay. Anyway, you can take this and put them like this. 4x plus 20 divided by 10x equals to 3x minus 10 divided with 4x plus 20. Okay, so we have seen a few questions like this before this. Okay, 4x plus 20 square equals to 3x minus 10 times with 10x. Okay, so this will give us 16x square plus 160x plus 400 equals to 30x square minus 100x. Okay, so let's transfer everything to the left hand side. So this will give us a negative 14x square plus 260x plus 400 equals to 0. So we get a quadratic equation. So try to solve this quadratic equation. I give you a few minutes. Okay, so you can use your calculator to find the answer. Okay, so x actually equals to 20 or negative 10 over 7, right? Okay, so if you put them in a bracket, it's going to be x minus 20 x plus 10 and 7 here. Okay, but the problem is x times 7x will not give you negative 14x square, so there's a missing link. Okay, so in order to fill up this missing link, so you have to divide the whole thing with negative 2. So by doing that, you can get 7x square, okay, what you call minus 130x minus 200. Okay, okay, otherwise you will lose marks in exam, huh? Okay, since we are talking about length, x cannot be negative, x must be a positive value. Okay, so in this case tan x is going to be, okay, 10 times 20, 200 centimeter. 4x plus 20, 4 times 20 plus 20, this will give us 100 centimeter. 3x minus 10, 3 times 20 minus 10 is equals to 50 centimeter. Okay, so in the question it's given that this is actually the second longest, okay. So meaning this is T2. The question asks what is T1. Okay, by looking at the sequence, right, you can see that divide by 2, or in other words, this actually multiply with 1 over 2, multiply with 1 over 2. So R is actually 1 over 2. So in order to find T1, or the longest is T1, okay, what we need to do is 200 multiply with 2, okay, because if you reverse the process, it's going to be, okay, times with 2. How to know the sequence is big to small, not small to big? Question I didn't mention. But anyway, when you look at the second part, right, B, okay, if we relate this problem is sum to infinity, okay, the length of the pieces must be reduced, okay, otherwise we cannot use sum to infinity, okay. So B, sum to infinity, okay, find the maximum length of the wire. Okay, so we have a long wire and then we cut it into, okay, small pieces where the length of these pieces actually keep on reducing. Okay, so the question asks what is the original length of wire. Okay, meaning when you sum up all these small pieces, you're going to get the original piece of wire, okay, which is equal to sum to infinity. So sum to infinity is equals to A, the first term, the first term is actually 400 divided by 1 minus R. So what is the value of R? R is 1 over 2. Okay, and you're going to get 800 centimeter. So 800 centimeters is equivalent to 8 meter. Okay, now let's see how to solve the second question. But before that, I want to make some correction to this question. Okay, so the correction is going to be, okay, form the first three terms for the parameter. Okay, so okay, I want to change it to length of arc, okay, of the semicircle in terms of R. And then for B, find the total length of the semicircle in meter if the spider web has 15 semicircle and each radius, okay, not each radius, okay, cancel the each and replace with smallest radius, okay, smallest radius is 2 centimeter. Okay, now let's see how to solve this question. Okay, so first of all, T1 is going to be the radius, okay, radius for the smallest semicircle, okay. And how about T2? T2 is going to be, okay, 1.4, okay, of the previous radius. Okay, why 1.4? Okay, so it's because of the original length is going to be R, and then we're going to get an increment of 40% of the previous radius. 40% means is 40 over 100, where I'm going to write this as 0.4 R. Okay, so when you sum up this, you're going to get 1.4 R. Okay, 1.4. And R3 is going to be, sorry, what do you call? Okay, first I'm going to write R1. R1 is actually R, and R2. Okay, R2 is actually have an increment of 40%, okay, compared to the first radius R1. Okay, meaning you're going to get R plus, okay, 40% of the first R. So meaning it's going to be R plus 0. R, and later you can write this as 1.4 R. Okay, and how about R3? R3 is going to be, okay, R2 plus 40% of R2 plus 40% of, okay, R2. So this is going to be 1.4 R plus 0.4 times with 1.4 R, and later you can write this as 1.96 R. Okay, so from here, okay, we can calculate the what you call the common ratio R. So please differentiate the R with the common ratio R. This R is actually radius. Now, so what is the common ratio? The common ratio, okay, better I write common ratio. Common ratio R is actually 1.4 R divided by R, which is equals to 1.4. Okay, actually you can put this calculation much more easier. Since the increment is 40%, so the R is going to be 100% plus 40%. So altogether it's going to be under 40%, and later you can convert it into 1.4. Is that okay? So you can simplify the whole calculation. So R1 is R, R2 is 1.4 of R, and R3 is 1.4 times with 1.4 R. I mean 1.4 times with R2. So later you get 1.96 R. Okay. Next, how about the length of arc? Okay, which I can write this as S1. Okay, small s represent the circumference, okay, or the length of arc. Okay, so don't get confused with the sum. Okay, now S1 is actually can be calculated using the formula, okay, pi r. Okay, so pi r1. Okay, and then S2 is going to be pi r2, and later S3 can be calculated using pi r3. So this is going to be pi r, and this is equals to 1.4 pi r, and then this is going to be 1.96 pi r. Okay, so if you calculate the common ratio for the sequence of the length of arcs of the semicircle, it's also going to be 1.4. Okay, so since the question asks the length of arc, okay, the first three length of arc, so the answer is going to be, okay, pi r, 1.4 pi r, and then 1.96 pi r. Okay, now let's proceed with section B. The question asks the total length of the semicircle. Okay, so here the question is actually just asking you to find the total length of this part. Okay, so what happened to the length of this, okay, this particular section if we have 15 semicircles and the radius of the smallest, okay, semicircle is actually 2 centimeter. So for section B, okay, so T1, so T1 is actually the length of arc for the first semicircle, which is pi r. Okay, so pi, so since the radius is 2, I'm going to make it into 2 pi. Okay, and then I already discussed how to get the value of r. Okay, so we straight away going to write the r 1.4, and then we have 15 semicircles, so n is going to be 15. So the sum of all these 15 semicircles, right, I mean the sum of the length of all the 15 semicircles, okay, S15 is equals to A, which is 2 pi, times with 1.4 to power of 15 minus 1 divided by 1.4 minus 1. Okay, and if you solve this, you're going to get 2428.26 centimeter, okay, which we can round off as 2428 centimeters. And in this case, actually I use pi equals to 3.142. Okay. Okay. But since the question asks you to write the answer in meter, so let's convert this into meter. So the answer is going to be 24.28 meters.